time for some iron strong water. That tasted horrible. What is going on? Lately I've been feeling all fatigued and nauseous. And my skin, after I take a bath, has been feeling all wrinkly even though I'm only 17 years old. Could this be something to do with iron contaminated water? Looks like I have to go have a chat with this company.
Dr. Nikhil Khanderkar. What was all these long lab reports?
Hey, I need to have a talk with you on the condition of your water. It's been really stinky. Ooh, cream for my wrinkles and my symptoms. Oh wait, your water is really horrible. We need to talk about it.
Oh, that's really easy to deal with. There's $1 for a refund.
Hell no. I've been feeling so sick lately and so fatigued. Your water, there's something wrong with your factory. We need to talk about it, and I'm taking you to court.
Well, see you in court then.
Good morning, ladies and gentlemen. Calling the case of Abhi Bhargava versus Iron Strong Water Company. Mr. Anthony Wang, I've been told several complaints about the purity of your water by plaintiff Mr. Abhi Bhargava. He has sent me several testimonies about the water and the inherent problems it has of the containing of excess iron causing symptoms of fatigue and wrinkly skin. As a consequence, you are going to tell me exactly how water is being purified to remove some of the iron content in your water. However, even before you do that, you have to answer a couple questions about iron treatment process just to make sure you're not a fraud. Okay, Mr. Anthony Wang, let's start with the basics. What exactly is clear water iron? And can you explain to me how is it coming into our water?
Yes, Your Honor. Clear water iron is a ferrous form of dissolved iron with 2+ charge. It is found in water that is not exposed to oxygen, such as in wells and springs. On a normal basis, when water travels through rocks, the iron dissolves and accumulates in aquifers.
Can you please elaborate on this concept of aquifers?
It's a body of permeable rock that can contain or transmit groundwater. There are unconfined aquifers and confined aquifers. Unconfined aquifers are situated right beneath the ground surface, where water can seep right in through the aquifers from above the ground. Confined aquifers are further away from the ground surface. There's a layer of impermeable dirt or rock. A layer exists in between that prevents water from seeping into the aquifers from the ground located directly above. Thus, unconfined aquifers has high dissolved iron concentration than confined aquifers.
Good. Then, why exactly is iron hardly found in surface water but very commonly found in our groundwater?
Because there are more oxygen atoms dissolved in surface water than groundwater, since it's closer to air, the iron in the surface iron will form oxide compounds which are insoluble in water.
Just adding on to that, I heard that surface water has a slightly higher pH than groundwater. Does this have anything to do with the iron content in our water?
Yes, Your Honor. The normal range for pH in surface water system is 6.5 to 8.5, and for groundwater system is 6 to 8.5. Because groundwater has a possible pH of lower than 6.5, it is more acidic. Thus, groundwater could leach metal ions from aquifers, plumbing fixtures, and piping due to the corrosive nature of acidic water.
Okay, well, it really does seem like you know your stuff. But here comes the real test. You're going to explain us how your company actually cleans the water. Provide us with all chemical mechanisms that are associated with this challenging but really important task.
Yes, Your Honor. The most common way of removing ferrous iron from water is by oxidizing it to ferric oxide, then removing the insoluble ferric hydroxide particles through basic filtration. This filtration portion is actually the key to the whole process.
Where does something wrong happen then during the filtration?
Failure to filtrate the rust particles in water will leave rust particles in water, rendering the whole process fruitless. Low level of rust in the water may not be harmful to health, but very high levels of iron can lead to iron overload, which in turn could lead to a disease which poisons the organs and can lead to cancers and irregular heartbeat.
Wow, that's really sad actually. But can you tell me exactly what you do to oxidize the iron content in your sampling to prevent that from actually happening?
Yes. I use a process called aeration. It is the most cost-effective and environmentally friendly method to oxidize iron. Iron is easily oxidized by the atmospheric oxygen. Aeration adds oxygen to the water so that it may oxidize the iron. In aeration, oxygen is added to the water by bubbling the oxygen gas into the water. The reaction that happens is as follows. It takes approximately 7 mg dissolved oxygen to oxidize 1 mg of iron.
Okay. So then just tell me one last thing. What factors influence aeration and water contamination?
Well, this reaction is heavily dependent on the pH of the water and the airflow of the aeration. Without either of these can lead to nasty results. If pH of the water is too high, which means not enough H+ ions, then iron may not be fully oxidized. If you have high airflow, an excess of dissolved oxygen will be left in the water, speeding up corrosions in the water pipes where aeration is occurring. Corroded water can hurt the efficiency of heaters and can cause plumbing failure. Additionally, high level of lead and copper in the water corroded from the pipes can lead to chronic health problems.
Well, it does seem like you do know your stuff. I can't find a single thing in the entire process that actually seems fraud-like.
Hold on. Your Honor, I'm afraid that's not true. I can identify several issues with this process, which explains why Anthony's water still has high iron concentration and also not very cost-effective. Could even filter out some of the good water. It's a waste of resources.
No, my technique is perfect. You're lying. He's lying, Your Honor.
Silence, Mr. Wang. Mr. Bhargava, please elaborate.
Thank you, Your Honor. First, Anthony's technique for oxidizing the iron seems alright, but the real problem resides with the method of filtration. You see, Anthony uses a form of media filtration, which is not only very expensive, but the process can reject clean water that can even have no iron content in it.
Huh. Well, this media filtration technique you talk about does seem really intriguing. Can you provide us with some more details about this?
Of course I can. Media filter is a type of filter that uses a bed of sand, peat, shredded tires to filter water for drinking, swimming pools, aquaculture, irrigation, stormwater management. This technique filters the ferric hydroxide particles through a thick layer of sand. Thus, this method depends on the speed at which the water is being dropped along with the surface area of the sand, which is used to trap the ferric hydroxide particles. However, the problem with this method is that the media filtration tends to filter even clean water that is pure, like I mentioned earlier. Lastly, the iron bacteria causes the media particles to stick together and allow unfiltered water to flow freely through gaps created in the filter media. Ultimately, the filtration quality drops over time, and the unclean bedding causes bacteria and other unwanted organisms to thrive. Thus, this water is deemed to be impure because of the excess iron bacteria.
I can't believe I've been blinded by you, Mr. Wang. All this time, I'm putting you on prohibition, and if you don't turn your company around for the better, then further legal action will have to be taken.
Ah, dang it.
Anthony, if you want to save your company, you might just want to update your filtering system. I know Dr. Nikhil Khanderkar, and he'll be giving a presentation on microfiber filtration on May 18th, 2018. You might want to catch that.
The guy with long lab reports?
Hello everybody. Today I will be teaching you about a new water treatment system known as microfiber filtration. Currently, we are using a technique known as depth media filtration. Depth media filtration works by having unfiltered water in which there are particles known as colloids getting trapped through a filter media, which is usually composed of sand or granite, which is usually captures the colloids and then passes the purified water as filtrate into consumers' pipes. However, several problems have developed. First of all, through the usage of a filter media, water has been captured as well, which then reduces the amount of water which is going to a consumer's pipe. Furthermore, iron bacteria is known to cause filter media to end up grouping with each other, causing gaps in filter media to occur. However, iron bacteria is then passing through the filter media, which then implies that in the filtrate, we're having high concentrations of iron, which is known to be really toxic. A new method must surely be developed for this. Here's what I've been thinking of. we are going to use a microfiber filtration system. Microfiber filtration system will consist of a cartridge and a self-cleaning system. The cartridge is consisting of rigid plates which encapsulates many layers of threads. How it works is you have a cassette which consists of a rigid plate consisting of multi-textile threads which are wound. The type of thread and its tension define its level of filtration. These cassettes are combined to form a unified package which is attached to another cartridge and which is then installed in the filter house for a filter for other people's houses. As mentioned before, there's also a self-cleaning process. The self-cleaning process happens by having a backwash of water push and cause the cassettes to start to rotate and then take these FeOH thrice particles and then get them to flow out into a drainage system. This way, only pure water is then left through the pipes, which can then go through the filtrage system. As a result, several of these same devices are then put into a same tank, which we then use to make one tank, and we can compose of several tanks into a single factory. This system is not only cost reducing, but it also tends to have more purified water and also tends to be able to identify water that is completely pure more readily than depth media filtration. Hopefully companies will come soon to realize the benefits of having a microfiber filtration system. Not only is it cheaper for them, but also it will give us more purified water so that these CEOs won't have to worry about bankruptcy and further legal action taken on them. This is Dr. Nikhil Khanderkar presenting microfiber filtration. Please subscribe soon as I'm about to reach my 420,000 subscribers. Thank you.
Wow, that's a great idea. Look, now this new system of filtration not only reduces the iron concentration, but it also cuts my budget. So that's a double win.
Ever since you've implemented that system in your factory, I gotta say, this water's been really clean. Thanks a lot.
You got it, man.
Iron Strong Water.